Hi there, my name is László Molnár from Concorde Observatory Budapest, and the title of my poster is A Comprehensive Look at RR Lyrae Stars through High Precision Photometry and Astrometry. I'm presenting this poster on behalf of the Task Working Group 6, and I'm showing here some of our results from our upcoming test first light paper that's currently under review. For this work, we looked at over 100 potential RR Lyrae stars from sectors 1 and 2, and created differential image aperture photometry for them with András Pál's FITSH code. With this method, we were able to extract light curves, as shown on the right, even from dense fields towards the Magellanic Clouds. One such example of a dense field detection is shown at the bottom row of images. TESS was able to provide us with accurate light curve shape information, but for proper classification, we also used Gaia EDR3 data and computed the absolute magnitudes of these stars as well. This plot shows that RR Lyrae stars cluster at a narrow brightness level between 0 and 1 absolute magnitude in G, and intrinsically fainter variables can be easily filtered out even if their light curves look very similar to RR Lyrae stars. We also use Gaia EDR3 data to create period luminosity and color magnitude diagrams for these stars. On these, the hotter overtone stars in blue nicely separate from the cooler fundamental mode stars shown in red. The double mode stars, shown with empty boxes, form the interface between these groups. Only a few targets were affected by inaccurate extinction correction, shown with crosses. Those are in the foreground of the LMC. The TESS photometry is able to reveal sub-millimagnitude level extra modes hiding behind the dominant radial mode in these RR Lyrae stars. We found these extra modes in 35% of RAB and 81% of RST stars, and in 100% of RRD stars, although we only had 5 of those. In the fundamental mode stars, we see a clear difference between the bar stars observed by the August survey, which dominate the short and the long period edges of the distribution, and the field and halo stars observed by space telescopes like Corot, Kepler, and TESS that form the middle of the distribution. This plot suggests that there is some difference between mode excitation in the bulge and in the more metal-poor halo stars. We observe similar differences in overstars as well. RRC stars in the bulge and in metal-rich globular clusters like NGC 6362 populate the left side of this Petersen diagram, whereas stars in the halo or in more metal-poor globular cluster M3 are shifted to the right and a bit upwards as well. This again clearly shows that metallicity is affecting mode excitation in RR Lyrae stars, and these observations will undoubtedly influence theoretical calculations. We can use the TESS-GAI synergy to plot the distribution of these extra modes in field stars onto the color magnitude diagram as well, and we do this for the first time for field RR Lyrae stars. It appears that extra modes dominantly appear in cooler overtone stars on the left plot, shown with darker outlines, whereas the extra modes seem to favor hotter RR AB stars, similarly shown on the right plot with outlines and crosses. And the edges of the instability strip are predominantly populated by pure radial pulsators. Overall, we detect not only metallicity dependence for mode excitation, but we also see a dependence on color or effective temperature as well. However, identification of these modes will be difficult. There is a strong coupling to the dominant radial mode that creates a series of linear combinations peaks in the frequency spectrum. And if we create an echelle diagram with the dominant radial mode, these series will form straight ridges on this echelle. And while these ridges form at very similar frequency modulus in several stars, the position of the strongest peak in this series may vary significantly. This makes it unclear if you observe the same modes in these stars or not. And this will be an important open question in our future research. More on this and our other results will be in our upcoming RR Lyrae first light paper. Thank you for your attention.